Hello again from Digicool Things. This follows on from my introduction of the Minimalist Europe Card Bus, MECB, where I outline my preferred design for recreating some of my 8-bit CPU experiences from the late 1970s and early 1980s. For this modular bus-based system, the first thing we'll need is a backplane for connecting our modular boards together. In my Minimalist Europe Card Bus background and introduction video, I came to the conclusion that I would first develop a standardized mechanical specification for a minimalist ECB board. This was completed, providing the basis for my first MECB board design to get underway, while ensuring that all the MECB boards that I developed will be consistent for a tidy and attractive system solution. So, based on the MECB 100mm square board size, let's take a look at our preferred backplane design parameters. Firstly, there's space for 4 64-pin row A and C DIN 41612 female backplane connectors centered across the board width. A 5th right-angle female DIN connector to facilitate mounting a board horizontally for ease of access during hardware or software debugging, and also for prototyping board development. The horizontal connector could also allow for a future backplane extension board. We have multiple 5-volt power connector options, including a DC power connector, a modern USB-C power connector, and a screw terminal connector to support any other desired power source. We have a power switch to allow switching on and off the power of the backplane connectors. Some backplane bypass smoothing capacitors, perhaps 100 microfarad and 10 microfarad would be appropriate, leaving the smaller 0.1 microfarad typical bypass values to be located close to the ICs on each MECB modular board. And we want to use only through-hole components in keeping with the early 8-bit retro MECB theme. And a few design notes. There's 6 M3 mounting holes provided for mechanical support as per the standardized mechanical specification. We have a USB-C receptacle module which mounts with pin headers. This is used to facilitate through-hole components only. And I found some low-profile 100 microfarad capacitors just to make a nice clean and tidy finish. As expected, a backplane design makes a relatively simple schematic. So let's just have a quick look at the schematic. This has been completed in KiCad based on the standardized mechanical specification KiCad template that I created earlier. As you can see, I have a total of 5 DIN connectors. 4 are straight female, and the 5th is a right angle female connector. Then we have the various 5-volt power input options, some bypass or smoothing capacitors, and a total of 6 mounting holes. And after some tweaking, here is what the final PCB layout looks like. So we now have a backplane PCB design ready for my first backplane build. And here are my revision 1.1 backplane prototype PCBs delivered from JLCPCB. I think it looks great in my preferred blue colour for my retro PCBs, perhaps because my old 80s Eurocard wire wrap boards were also blue. So let's lay out the components and see what we need to complete this first backplane assembly. We have our PCB. We have total of, there's 2, another 2, we have a total of 4 64-pin DIN Type C straight female connectors and we have one right angle female connector. Okay, and we have a power toggle switch, a DC connector, a screw terminal connector, and also our USB-C module for power. Now we don't actually need all those power connectors, as you could just solder in the ones you intend to use, but I think for my first build I'll fully populate the board. Okay, then we need a couple of these low profile 100 microfarad capacitors. And we'll have a 10 microfarad capacitor. And finally some M2.5 DIN socket mounting nuts and bolts. Let's see, I have some 8mm ones here. The 8mm length bolts are for the straight connectors, so we'll need 8 of those. And the 10mm bolts are used for the right angle connector, so we'll just need 2 of those. And of course we'll need 10 nuts to go with those. So let's get started by soldering in the capacitors. They'll probably be the lowest profile components. Right, so let's fit the capacitors. We've got our 2 electrolytics, which are polarized. So I'll just put those in around the right way. And just bend the leads over a little bit to hold them in place while I'm soldering them. And we have our 10 microfarad. This one isn't polarized. And we'll just bend those pins a little bit as well so that doesn't fall out while I'm soldering. Right, let's get those soldered in place. Okay, let's clip those leads. Okay, we have some bypass capacitors. So having mounted the capacitors, the next lowest profile components will be the power connectors. So let's start with the USB-C power module, which you can see I've already soldered on a 4-pin header strip. Now we just want to mount that here and get it horizontal. So to help me with that, I might use a couple of aids here. I've got a little breadboard I can sit that on, and I'll just prop up the other side and we'll see if we can get that tacked on. That looks fairly good. So let's solder up the rest of those. Rightio, now we just need to add the other 2 connectors. So he goes there, and our DC connector goes there. So let's flip that over. Now I'm just going to use a larger tip on my soldering iron because there's quite a large earth plane here absorbing the heat. So you can see I've got a larger tip on my iron here. See if I can get this tacked in place. Okay, we'll have a closer look at that as well. Alright, so I'm pretty happy with those. Okay, so I think the next thing is going to be mounting the DIN connectors. Now I think the easiest way to solder these is probably going to be for me to actually bolt them to the circuit board, because that'll hold them in place nicely for soldering. So the other thing to point out is that these DIN connectors, obviously some thought went into their design because the mounting hole is slightly off center, if you can see that, which is a design feature, which means you can only put it in the circuit board one way round, otherwise the mounting bolts wouldn't fit. But aside from that, you can see the key part of the connector. There's a little notch out of the end there, and that's also indicated on the silk screen. So there's no way I can get these around the wrong way. So let's just try fitting one first. Drops into its holes. And that's going to be quite nice, I think. Okay, so we need the 8mm bolts, and there's actually, the connectors themselves actually have a hex cut out, so when you put the nuts in, they actually lock the nuts, which makes it so much easier to screw these on. I'll just find a screwdriver, that'll help. And let's put one on the other side. These obviously just need to be finger tight. Right. Let's get that soldered. I'll just do these end ones first because I should have probably left the larger tip on my iron, because these are the power and ground pins. A lot of the heat's being absorbed by the ground and power planes. Right, and then back to the signal pins, which will be a lot easier to solder. Okay, so that's one connector soldered in. Now I'm not going to bore you with watching me solder the other 4 connectors. I'll just get that done and then we'll be back. Okay, so we now have all the connectors soldered in place and our backplane is starting to look more like a backplane. So there's only one more component to fit, and that's the power switch, which slots in nicely in this corner spot here. So I should be able to just solder that right there without putting it in my solder jig. Right. Okay, so the last thing I'm going to do for today is I just thought I'd grab some PCB standoffs just as a temporary measure. Because what I'll probably end up doing is create perhaps a 3D printed platform that this can screw down onto. Okay, and there we have our first assembled MECB backplane. Now there are two other mounting holes in the mid positions on each side to provide plenty of support. Just for now I'll just use the four corners so it sits nice and flat. We're ready to test once we've got some boards to plug into it. So until then, that's it. Thanks for watching.